Good morning. Nope, actually, it is afternoon. It is officially 12:08. So, happy Monday and good afternoon. We are going to start by going over your homework from Friday. I would say of the 11 people who turned it in, 8 of you were like really on track. And so I'm not going to go over every single question, but I'm going to go over a lot of them. So I can help you troubleshoot. Now you can see I've already started going over it. I am not going to go over 9 through 11 because 11 out of 11 of you got it correct. So that's wonderful. So proud of you there. But I do want to look at 12 through 17. Okay. So I have started 12 through 15. Now 16 and 17 I have a star because they were missed the most. And number 15 actually as well. But 12, 13, and 14, take a minute to look at these. And see how they're labeled. I'm just going to quickly go through how they should look and then should we multiply or divide. Okay, so on number 12, we should have the opposite in the adjacent side, which is, labeled like so. And then because our x is in the numerator, that means we're going to multiply, okay, to get rid of the 8. And so when you type that in, x is approximately 26.17. A couple of us rounded incorrectly, but that's not the end of the world, okay? We still want to be precise, but at this point, since we're still kind of learning, that's not the end of the world. All right, on this one, number 13, we should have the opposite in the hypotenuse, so it should be sine. And then because our x is in the denominator, we should divide, okay? So the way we should type it in is this. Okay, and so then x is approximately 13.77. So if you're getting these incorrect, if you got these incorrect, the few of you who did, please go back and see if you can, hopefully you have your work written down from Friday and you can, make your corrections. All right, number 14 is also a division problem because x is in the denominator. I remember that because of the d's, denominator, divide. So we should do 7.6 divided by cosine 38. And then x is approximately 9.64. All right, now 15, I think some of you may have had this backwards or labeled them incorrectly, but notice that the hypotenuse is always across, and then this is adjacent because it's beside, okay? So that's cosine. And then a over h is x over 10, and so we're going to multiply by 10 here, okay? And so 10 times cosine 20 is approximately 9.40. So it was let me write this down. It was 9.396. So that 6 tells the 39 to bump up, okay? All right, so why I have a star by 16 and 17 is you can do this problem using SOHCAHTOA. I'm going to show you that. Number 16, or actually both of them, but you actually didn't have to. If you notice, this is a 30, 60, 90 triangle. Okay, so if that doesn't stand out to you, maybe it will now. And so that's the 60. And if you remember our old from a couple weeks ago, we would label the hypotenuse 2x. Across from the 30x, and then this would be x root 3. And so we would do 2x equals 10 root 3. We would divide by 2. And so then x equals 5 root 3. Now that's not the side we're looking for, so we're going to plug it in here. Okay, so we're going to do 5 root 3 times root 3, which is 5 times 3, which is 15. All right, so that's one way to do it. Or you could do SOHCAHTOA still. All right, so I'm going to I didn't plan this space out, but that's okay. Let's add a new page. And then I'll go down below. All right, so another way we could do 16 is we could do, let's label it using red. Okay. So we could call this the adjacent side and this the hypotenuse, so that's cosine. So cosine of 30 degrees is adjacent over hypotenuse. And then is that multiply or divide? And it is a multiply. Okay, now I'm going to show you in Desmos how the calculator, how you type this in. Now it's actually equals, it's not approximate. All right, so we're going to type in 10 root 3, 10 root 3. Now here's where you have to be careful. You have to hit the over arrow so the radical stops, okay? And then times cosine 30. And hit enter. So 2 ways to do this problem, and you get the same answer both times. Okay? So if you could notice the 30, 60, 90, the special right triangles, that's awesome. But the nice thing is you don't have to. You can do this using the trig. Okay? And then the same thing is going to happen for number 17. So this is a 45, 45, 90 triangle. And the reason I know that is because I have isosceles triangle. The two legs are congruent. So that's x, x, and x root 2. And so then if you just notice the root 2's match up here, so that means the x and the 4. So x equals 4. That's your answer. Another way you could do this is you could call, the problem with doing SOHCAHTOA here is you could do SOHCAHTOA, but you don't have a theta anywhere. I'm just drawing it really quickly. So you don't know where your theta is, so you could just plop it anywhere you wanted to. Put it there if you want. Then we can label our sides. So this is our hypotenuse, and this would be our adjacent. Okay? So then we would have cosine, I didn't mean to put theta. I really should have put 45 degrees, I'm sorry, in here. All right, equals, and then our adjacent over our hypotenuse. And then you can multiply. The hard part about this is you did not know 45 unless you kind of made that, you didn't know to put 45 there in the spot unless you automatically identified that it was an isosceles right triangle. All right, then we can type that in. So 4 root 2, don't forget to hit the over arrow, and then times cosine 45. And there you go, you get 4. Okay? But honestly, if you could have noticed the special right triangles, the 45, 45, then that answer would be done very quickly. All right, so go back and check your answers carefully and try to find your mistakes if you made any. There weren't many mistakes, but there were a few, and especially with these last two, okay? All right, so now we're going to go on to the new stuff, which technically isn't really that new. It's just kind of looking at what we've learned already in a different light. I'm going to have a sip of water. Excuse me. Okay, so actually the first part of this, like if we were in class, this would be your warm-up. These first 3 problems is one more time trying to get you to understand the relationship between sine and cosine of different angles. So let's just work these really quickly and then we'll get into the new stuff. Alrighty, so with the first triangle, it says, what is the sine of x? So sine is O over H. I'm going to go ahead and write SOHCAHTOA. Hope y'all are kind of confident with spelling it now at this point. Alright, so sine is O over H. So according to x, our O is 8 and our H is 17. All right, now it's asking us for cosine of y. So cosine is A over H. So our A is 8 and our H is 17. Now, I hope some of you knew that that was going to happen already. Remember, the sine of one angle is going to equal the cosine of the other angle, and then vice versa. The cosine of one angle will equal the sine of the other. Okay, so this is kind of looking at the same thing. What is the sine of 57? So the sine of 57 is O over H. And then the cosine at 33 is A over H. Okay, and I guess technically I should have labeled this. Let me go back and do that. So this is our H. This is our H. And then obviously the O and the A are going to switch depending on, which one we're looking at. Okay, whether it's sine or cosine. Whether it's 57 degrees or 33 degrees. So, nonetheless, we need to make sure we understand that the sine of one angle and the cosine of the other will always be equal to each other. So now the next one looks a little tricky because I don't give you any of the side lengths at all. And so we can't write it in fraction form. So we're going to have to write it in terms of the other angle. So the sine of this angle is going to equal the what of this angle, and it's the cosine. Okay? So that's yet another way we can write it. We practiced that in the notes on Friday, or maybe Thursday, I can't remember now. Remember how we typed in the calculator this, and they should be equal to each other. And then the last thing here is how to write it in an abstract case, meaning if we know theta, that's just one angle, how can we write its cofunction? Well, if we have the word cosine, what has to go in the blank? It's the opposite, so we're going to write sine. And then if we know this angle is theta, how do we figure out what this angle is? It also cannot be named theta because we've already called the other angle theta. But we know a relationship between these two angles. How much do they equal? Well, together they equal 90 degrees, right? So if we know that this angle would say, let's say it be 40 degrees, then we know this angle would be 50, right? Because we just subtract 40 from 90. So that's all that I'm asking you to do here. If they together equal 90, and this is some random angle theta, the way that we're going to find this angle here is by just doing 90 minus theta. And that's what we write in here. So because they equal 90 degrees, if we subtract whatever that random angle is from 90, it'll give us the angle. This is what we call the abstract case, but it's also like a rule, meaning it'll work every single time. So if we go back to this previous example, the way that we can find 41 degrees if we didn't know it was to do 90 minus this one. Right? And 90 minus 49 does give us 41. Okay? And then you could see that relationship here as well. If we took 90 minus 57, we would get 33. Or if we did 90 minus 33, we'd get 57. So the sum of the angles should always equal 90. Okay? All right. If that doesn't make sense, it's not the end of the world. It's just one of those like shortcuts. So like you could have figured these two problems out right here immediately without the shortcut. Okay? All right, so now we'll get into the notes. So we're going to do word problems today. And a lot of times what I would tell y'all if we were in class would be go ahead and do some sighing if you want to. A lot of students get discouraged by word problems and think they're a little difficult, but I promise we're going to kind of work on what to look for in these word problems to help it not seem so difficult, hopefully. Okay, so the first thing we're going to talk about is the difference between elevation and depression. So if you think about elevate, or you think about like angle of elevation, think about an elevator or escalator. If we elevate, we're going to be looking upwards, okay? Is going to be looking up. Then the angle of depression might be kind of, you know, how some of us are feeling right now, not being able to see our friends or go out in the real world. I know I feel like that sometimes. Depression, you know, means we're feeling down. So it's also looking down. All right. The angle, oops, I should have put angle. I'm sorry. And this one is the angle of depression. Is the angle looking down. Okay? So if you notice in this first picture, is this person looking up to the tree or looking down to the tree? So this person is looking up because the tree is higher than the person, right? So they're looking up. That's the angle of elevation. And it is always going to be inside of the triangle. Okay? Now with this one, the person standing at the top of the lighthouse, and he or she is looking at a boat in the distance, so we're having to look down. Okay? Now, if you notice, we have a triangle drawn, but where is this X located? It's actually located outside of the triangle. Okay? So that doesn't seem like it's really going to help us because it needs to be inside the triangle to be able to do, you know, SOHCAHTOA or whatever. That's what we're going to use most of the time, or unless it's a special right triangle. So we're going to use this concept that we've learned before. Okay, so let's see if I can highlight this. All right, y'all remember parallel lines cut by a transversal? And what do we remember about these angles right here? That's really terrible drawing, sorry. But you know they're alternating the transversal and they're on the interior of the parallel lines. So if we have a parallel line cut by a transversal, alternate interior angles are congruent. So the angle of depression, even though it's outside, is going to be the same as the angle of elevation because of alternate interior angles. And maybe it would help to review, to refresh your memory of the Z or the N. Remember that? And so you can kind of see the Z there. Maybe I should do it in a different color than yellow. All right, you can kind of see the Z there. And so then that will help you understand. So basically, the moral of the story is they start off in different places, the angle of elevation and the angle of depression, but they end up in the same spot every time. Okay? All right, so I'm going to do 6 examples with you, and then you're going to do 5 examples yourself. Okay? All right, so we are going to work these problems the same way every single time. We're going to read the question, we're going to sketch the picture, and then we're going to set up the trig equation and solve. All right, so let me kind of refresh your memory. On these problems 12 through 17 on your homework, the picture was already drawn for you. The only additional step in these problems is that we have to draw the picture. However, I will tell you that is where students struggle. Okay, so I'm going to go ahead and say, you know, I'm a creature of habit. I literally am going to draw the same triangle on all of these. And then we'll just make it work for the problem. Okay, I'm not trying to be an expert drawer or anything. If Mr. Thomas were here in the room helping me, he could draw some stuff for me, but he's not. So we're just going to do our best that we can and draw, you know, to the best of our ability. Okay, so let's do, sorry, I just got a quick text message I need to check. Okay, so it says a tree casts a shadow 21 meters long. All right, so as we read these, we're going to try to figure out where would these numbers go in a triangle. Are we going to be going up? If we're talking about a tree should be, you know, like that. A shadow is typically cast. Now, you can see shadows wherever, but we're going to talk about if we're looking at a tree, the shadow is going to be here on the ground. Okay? And then angle of elevation is 51 degrees. What is the height of the tree? So that's what we're looking for. That's going to be our X or our unknown. So we're going to label this. We need to put the 21 somewhere. So a shadow's on the ground. So 21 meters is going to go here. The angle of elevation is us looking up. So the angle of elevation is going to go here. And then the height of the tree is our unknown or our X. And the height of the tree would go there. So does that kind of make sense with everything that we have in the picture? All right, so we're going to do now, if you want to redraw the picture so it's not so big. I'm sorry, it's kind of messy. So we're going to have 51 degrees in here, 21 meters here, and X here. And now it just turns into a problem like what we had on Friday. Okay, so now we're going to label it according to the 51. This is our O and this is our A. So which trig function uses O and A? And I'll write SOHCAHTOA up here again. All right, so TOA is tangent. So we're going to write tangent. Always the angle comes next, and then O over A. All right, and now we need to either decide is it multiplying or dividing. And it's multiply since our X is in the numerator. So we're going to times by 21. And so X is approximately, and now we're going to type it in. And we're going to go to Desmos and we're going to type in 21 times tangent of 51 and hit enter. And we're going to round to the hundredths again. So that's 25.932 So it's going to stay 25.93. And then we don't want to forget our units because this is a real world problem. So that's going to be meters. Okay. All right, let's look at another one. A small airplane climbs at an angle of 18 degrees. So you guys, when a plane takes off, right, is that increasing or decreasing height? So that's increasing. So it's going to be like the angle of elevation, okay? The angle in which the airplane climbs. Find the horizontal distance. So you guys, there's a context clue. So is horizontal this way or is horizontal this way? Well, this is vertical, so that's not it. So vertical is not there. We're going to put the horizontal distance here. Find the horizontal distance, so that's our x, when it has reached an altitude of 800 meters. So you guys, altitude is another name for height. And height, remember, is always straight up and down. Okay? And so now we can set up our trig equation. All right? So our trig equation is O over A. And so is everybody clear? This is our angle, so this is our opposite, and this is our adjacent. So again, that is tangent. They're not always going to be tangent. It's just working out that way. Okay? And so now it is a divide problem because our x is in the denominator. So we're going to type in 800 divide by 1018. And we'll get what x is. So 800 divided by 1018, and we should get, it's a big number, but it's because we're talking about flying an airplane, right? So it's 2,462.146, and so that 6 is going to make the 14 bump up. All right, so it was 2,462.15, and then our answer is in meters. Okay, so if you're thinking meters, meters is not very long. You know, it's pretty small. And we're talking about an airplane, a small one, so it's not going terribly high to begin with anyway. All right, so that kind of makes sense. All right, I just decided as we're working through these might be taking a little more time than I anticipated. So we won't do all 6 of these. I'll stop after the third one and then have you do the last ones. Maybe, we'll see. Okay. You are looking at a painting on the wall at the High Museum in Atlanta. You are standing 10 feet from the wall. So we're standing here. And the painting is here. All right. 10 feet from the wall. So that's like the base. Okay, so our 10 is going to go down here. Your angle of elevation is, so we're looking up, is 20 degrees. Your eyes are about 5 feet above the floor. Find how high the top of the painting is from the floor. So we're trying to find X over here. Okay? So this is O and this is A. Again, that's tangent one more time. So tangent of 20 degrees equals O over A. Okay? So we're going to times by 10 on both sides. And so then we're going to have X is approximately, so 10 times 10, 20. 3.639, so that 9 is going to bump the 63, so 3.64. Well, 3.64 what? What was our unit here? Our unit was feet. Okay? Okay, so I would like for you to try number 4. And then I would like for you to try number 6, and I'm going to do number 5 really quickly. Okay? So number 5 says, an operator at the top of a lighthouse sights a sailboat. So we're at the top of the the person's at the top of the lighthouse, and the sailboat is out here. Okay? The point from which the sighting is made is 24 meters above sea level. So 24 meters above sea level, that's like the height. The angle of depression is 10 degrees. So here's how I want you to draw angle of depression. So you want to look like your angle of depression is always coming straight out of your eyes, but then looking downward. So your angle of depression of 10 degrees is here. Okay? Now that doesn't do us any good. So by alternate interior angles, we're going to draw our little Z. Okay, so boom, boom, boom. So really, your 10 degrees also can go there by alternate interior angles. Okay, so technically, you guys, it is in the same location as the angle of elevation. It just doesn't start there. Okay, and then it says, how far is the boat from the base? So there's a keyword you want to look for. Base means the bottom, so X is down here. Okay. So again, this one is, according to this 10 degrees, this is our O and this is our A. Oh, and you guys, once you draw the angle of depression in the new spot, you can kind of ignore this one now. Okay? So then that's tangent of 10 degrees equals O over A. All right, so we're going to divide. And so now we'll get 24 divided by tan 10. So 136.11. And what was our unit? It was meters. Okay, so I would like for y'all to try 4 and 6. Okay, so when you fly a kite, remember you're flying a kite, it doesn't go straight up and down. So the kite's going to be like this, and then the kite's going to be like that, you know, and you're flying the kite here. So see if you can draw that and set it up. And then a guy wire is just like a wire holding a pole. All right, so the pole would be here, and then the wire would be here. Okay. You know, my drawing is lovely. Such an artist. Okay, so it's not a pole, it's a transmitter, but I shouldn't say pole, I should say tower. So the tower is going to be here, and the wire is going to be here. And it's the angle that the wire makes with the ground. So this is still where your angle is going to be. Okay? So I would like for you to try 4 and 6 only, and then we'll continue with word problems tomorrow. Sorry this was a little lengthy, but I think it's important that we kind of take our time. All right, great. Thank you.